Ever wondered how the methods of controlling circuits have evolved over time? Well, that's precisely what we're diving into today. Buckle up for a journey through time, tracing the evolution of circuit breakers. In the early days, switches and fuses were the go-to for controlling circuits. However, they had their drawbacks, including slow replacement times and limited ability to handle heavy fault currents. As power systems advanced, a more dependable solution was needed. Enter the circuit breaker, a piece of equipment capable of making or breaking a circuit, either manually or by remote control under normal conditions, breaking a circuit automatically under fault conditions, and extinguishing the arc formed during the breaking operation. A circuit breaker incorporates both manual and automatic control for switching functions. The automatic control employs relays and operates only under fault conditions. The mechanism of opening the circuit breaker under fault conditions has already been explained in a previous video on relay. A circuit breaker essentially consists of fixed and moving contacts called electrodes. Under normal operating conditions, these contacts remain closed and will not open automatically until and unless the system becomes faulty. When a fault occurs on any part of the system, the trip coils of the circuit breaker get energized and the moving contacts are pulled apart by some mechanism, thus opening the circuit. Now, when the contacts of a circuit breaker are separated under fault conditions, an arc is struck between them. This arc generates enormous heat, which may cause damage to the system or to the circuit breaker itself. Therefore, the main problem in a circuit breaker is to extinguish the arc within the shortest possible time so that heat generated by it may not reach a dangerous value. Circuit breakers can be classified based on the medium used for arc extinction. Oil circuit breakers use mineral oil to quench the arc. The heat of the arc decomposes the oil into hydrogen gas, creating a high-pressure environment that aids in arc extinction. However, they come with some disadvantages, such as the risk of fire and the need for periodic oil checking. Air circuit breakers use air and arc chute as the arc quenching medium. They employ high-resistance interruption methods, offering advantages like high-speed reclosure and less maintenance. But they can produce noise and face restriking voltage issues. SF6 circuit breakers use sulfur hexafluoride gas as the arc quenching medium. The superior arc quenching properties of SF6 provide benefits such as short arcing time, the ability to interrupt larger currents, and low maintenance. However, they are costly and require additional equipment for gas reconditioning. Vacuum circuit breakers use a vacuum as the arc quenching medium. They are compact, reliable, and have a longer life. Unlike other types, they generate no gas during operation. To recap, we've traced the evolution of circuit breakers from simple switches and fuses to sophisticated pieces of equipment capable of handling heavy fault currents. We've explored how they work and the different types based on the medium used for arc extinction. Each type has its advantages and disadvantages, catering to specific needs in power systems. The choice depends on factors like voltage, current, and environmental considerations. And there you have it, a journey through time, exploring the evolution of circuit control methods. If you found this video informative, don't forget to like, share, and subscribe for more content on the fascinating world of power systems. Until next time, stay curious and keep exploring.